Today we're doing a quick feature-focused tour of the Azure Keyvault, what it is, what it stores, and what you should know before using it in real projects. I'll keep it mostly educational, with a quick on-screen walkthrough of the portal. Keyvault is Azure's managed service for protecting sensitive information and cryptographic material. The big goal is keep secrets and keys out of code and reduce who can access them. Let's jump into the portal and see where everything lives. This overview page shows the Vault's basics: the name, the resource group, and the Vault URI. The URI is what apps and toolings use to talk to this Vault. From here, the left navigation is where the most important features live. Keyvault mainly stores three types of things: secrets, keys, and certificates. Let's look at each. On the Objects dropdown, first we'll look at secrets. Secrets are name-value pairs, like API keys, passwords, and connection strings. Next we'll look at keys. Keys are cryptographic keys, used for operations like encrypt and decrypt, or sign and verify. Often you can use the key without exporting it. Lastly, we'll look at certificates. Certificates handle TLS and SSL certificates. You can import, store, and help manage lifecycle, depending on your setup. To create a new secret, we'll go to Objects, Secrets, Generate and Import. Here I'll give my new secret a name, password02. We'll give it the new secret or the password. Content type is optional, but I fill it in as a best practice. You can set the activation and expiration dates, so rotation is intentional instead of accidental. So I'll set the activation date for today's current date and time. The expiration date I'll set for the end of the month. It'll be enabled by default. I'll give it a tag. And select create. One super practical feature is versioning. When you update a secret, you're creating a new version, not just overriding the old value. That's useful for rollouts, rollbacks, and safe rotation. So if I create a new version, the name is already populated, I'll just provide a new secret. And the content type. Now in this case, I'll select the activation date for the end of the month when the previous password expires. And I'll set this expiration date for the following month. I'll give it a tag again. Select OK and create. Now I have an old version and a current version. The current version becomes active in the future. The old version is still active, and we can determine that by the activation and expiration dates. This allows for smooth password rotation, and it's intentional instead of accidental. Most Keyvault problems and most Keyvault wins come down to access control. The mindset is least privilege. Give only what is needed to the right identity. In many modern setups, Azure RBAC is the preferred model because it's consistent with the rest of Azure. You'll typically see roles like Secrets Reader for apps, and you can keep admin rights very limited. Some environments also use access policies. The main point is still the same though. Tightly control on who can see and do what. Keyvault also supports network-based restrictions, not just who can access it, but from where. Depending on your requirements, you can restrict access to selected networks or private connectivity options. Under Settings, go to Networking. Here, we can allow public access from all networks, allow public access from specific virtual networks and IP addresses, or we can disable public access completely. We can also use private endpoint connections. This is the preferred method of connecting to a Keyvault in an extremely secure manner. We'll cover this in a future video. A big reason teams like Keyvault is auditability. You can track operations and access attempts, which helps with compliance and troubleshooting. If an app can't read a secret, this is often where you would start validating what happened. Under monitoring, we can look at insights to see when the last Keyvault attempt was. We can look at alerts if we have any alerting set up. We can look at metrics or a log analytics workspace. If a log analytics workspace has been set up, this would be collecting the data on the back end. In practice, apps usually access the Keyvault in one of two patterns. Either they retrieve secrets at runtime using an identity, or they reference Keyvault from configuration so the app platform resolves secrets for them. The recommended approach is usually to use managed identities when you can, meaning you don't store credentials for Keyvault access at all. Some quick best practices to keep in mind. Separate vaults by environment, like dev, test, and prod. This prevents accidental cross-environment access, like a dev app pulling a prod secret, and it makes access control and auditing way cleaner. Least privileged access. Only grant what's needed. Most apps just need read access to specific secret types. Admin roles should be rare and tightly controlled. Prefer managed identity. Managed identity means there's no secret to access secrets. Azure handles the credentials lifecycle, so you eliminate a whole class of leaks. Use versions and expirations for rotation. Versioning lets you roll forward and back safely, and expirations force rotation to happen intentionally instead of letting secrets live forever. Lockdown networking when required. In strict environments, identity isn't enough. Use network restrictions so the vault is reachable only from approved networks or private connectivity. Turn on logging early. Logging helps both audits and debugging. When something fails, you want an immediate trail showing who tried to access what and why it was denied. And that's the feature tour of our Azure Keyvault, and you've already seen how rotation fits into the lifecycle. In the next video, we'll cover a real app using managed identity and pulling secrets securely at runtime. I'm Andrew Sutcliffe, and thanks for watching.